Let's take a look at some problems with the intermediate value theorem, the extreme value theorem, Rolle's theorem, and mean value theorem. So we're going to take a look at these, and I'm going to use our calculator quite a bit today. So I'm going to go ahead and switch our view so that you can see my calculator as well when we're working through these problems. Now, this particular problem says to decide if mean value theorem can be applied on the interval from 0 to 5, and then give a reason for the answer. If it applies, then we have to go find the value that is guaranteed by the mean value theorem. So looking at problem number 1, I want to remind you that the mean value theorem requires that you are continuous and differentiable. So continuous, I know, is not a problem for absolute value, but I do have a problem at x equals 3, because if you remember, the absolute value graphs have a corner on them, okay? And we do not have a derivative at that corner. So this is the mean value theorem doesn't apply because f of x is not differentiable at 3. Okay, now let's look at the second one then. We look at g of x being -2 plus sine squared. That is continuous and it is differentiable. So we'll go ahead and find the value for the mean value theorem. So remember what mean value theorem tells us. It tells us that there's a place on the derivative that is equal to the slope of the secant line. Okay, so let's find that derivative. Derivative of -2x would be -2. Derivative of sine squared would be 2 sine, and I'm going to put a c in there, cosine of c, equals. Now, we are being asked to use our calculator on this one, so I'm going to go ahead and use my calculator. Let me put this function into y1. I'm going to put in -2x plus, and then to put in sine squared, I've got to do sine of x and square it. And then you might do zoom 6 just to get a standard graph viewing window. And I want to find the value at 5. So that's second trace number 5. Whoops, let me try that again. Second trace number 1, and we're going to put in 5. That gives us a value of -9.080 minus, then we'll put in 0, which will have a y value of 0 over 5. So now we're going to solve. Now, I hope you're realizing that 2 sine cosine is actually the identity for sine double angle. And then we can do this negative 9.08 divided by 5 in our calculator. And that gives me -1.816. So let's go ahead and add 2 to both sides. So we get that sine double angle equals 0.184. Now, friends, remember that we're looking for the angle here. So in my calculator, I'm going to do the inverse sine of 0.184 and set that equal to 2c. So that's second sine of 0.184. And that gives me 2c equals 0.185. And then again, I can divide by 2 there. And I get 0.093. That is our value that is guaranteed by the mean value theorem. So Let's keep going. This time we'll look at a few free response like questions, like those you might see on the AP exam. So you're being told that administrators at a hospital believe that the number of beds is given by this function, where t is measured in days. We want to find b prime of t. Now again, we are using our calculator. So I'm going to go ahead and put this function in y1. I've got 20 sine of x divided by 10, then close, plus 50. And then we want to graph that. I already knew I had a Zoom 6 window as standard window, so I'm going to leave it like that. Now it looks like we're probably not in a very good viewing window, especially if we were shifted up 50. So I'm going to adjust that viewing window a little bit. Let me go down here to the Y max. I'm going to just change that to 100. I think that'll be pretty good. And let me turn those tick marks off on the y-axis there. There we go. You can see our graph now. Now we're going to find the derivative. Let's use the second trace menu, and we want to choose option number 6, and we want to plug in 7. Just typing 7, you notice that the x equals shows up at the bottom of the screen, and we're told that the derivative at 7 equals 1.530. And this is in units. It's a rate, so it's beds per day. So what does that mean for this problem? Well, it means that since b prime of 7 is positive, the number of beds, number of beds is increasing on day t equals 7. All right, now look at B, asks us, okay, on the interval from 12 to 20, notice it's a closed interval, we want to know the maximum number of beds that are in use. So we're going to use this derivative together with our endpoints to be able to tell where the maximum happens. So we're going to take the derivative, set it equal to 0, find those critical points first. So I know that b prime of t would have the 20 times the cosine of t divided by 10 times the derivative of the inside, the 1/10. So I know that this derivative is 2 cosine of t divided by 10, and I need to know where that equals 0. So we are going back to our calculator. Now watch what I'm going to do, friends. I'm going to use my calculator, but I don't want to have to delete this function and then retype it. So I just highlighted the equal sign and press enter. That means that the calculator will store the function, but it won't actually graph it or use it. So then I can go into y2 and I can type in my derivative. And this is what the calculator will actually graph here. Now remember, we widened our Y max here, which making it a little bit difficult to see these. So I'm going to go back to a Zoom 6 here and see if I get a little bit different picture, which is a little bit better to see. The other thing is, remember, we're looking only from 12 to 20. So maybe I change my X min to 12, my X max to 20. And I might get a little bit better idea. You can see I do cross the x-axis right there. That's the value I need to find. So we're going to use second trace, option number 2. Move your cursor to the left of where you see it cross the x-axis. Press enter. Move your cursor to the right of where you see it cross the x-axis and press enter again and enter one more time. And the calculator finds that value for you. So you've got that t equals 15.708, and that's in days. Now remember, with extreme value, because we're actually looking for the maximum number of beds in use, we're going to test those endpoints and our critical point, which was the 15.708. Okay, but we're going to let the calculator do the heavy lifting for us. So going back to my calculator, this time I'm going to turn the derivative off and I'll turn the function on. So I'm going to have it graph the function now on this interval. Now remember, we changed our y min and max, so we may not see any graph. It's totally okay. We're still going to use that second trace option. We want the value option, and we're going to put in 12. You can see the answer for the number of beds at 12 days at the bottom, and that is 68.641. And then you can do it again, second trace number 1. This time put in the 15 point, well, I didn't do that. Let's see, second trace number 1. This time type in your 15.708. And that's 70. And then one more time, second trace number 1, and type in your 20. And this one you get 68.186. So what is the maximum number of beds in use? Okay, so that's asking number of beds. That's going to be 70 beds is the maximum there. So this is a great example of using your calculator to its full capacity, but you're still doing the analysis with your derivative. Okay, I've got a couple more for us. So this one says for the temperature of a cup of coffee, sounds yummy, is the temperature of the cup of coffee in degrees Fahrenheit t minutes after it's poured is modeled by this function. Find the value of f prime of 4 and then use correct units of measure to explain what this means. Okay, so we're going to go back to our calculator again. I'll go ahead and clear out both of these. And let's type in this function. I've got 68 plus 93, and I've got a parentheses point 91, close parentheses to the x power. I'm going to do a zoom 6 just to get started. Probably not going to see anything because the 68 is so large. But that's okay. I'm going to use the second trace feature to find the derivative. Second trace, and I'm choosing option 6 on this one. And then remember, type in a 4. And we get that f prime of 4 equals 6.015. It's a rate, so it's going to be the degrees per minute, degrees Fahrenheit per minute. So what does that mean in this problem? That means since f prime of 4 is positive, the temperature is increasing at t equals 4 minutes. Okay, I hope you are finding that those sentences are beginning to be formulaic, meaning we say the same thing every single time. We want to make sure that we're hitting all the right buttons and checking all the right boxes for those pre-response answers that we know are going to be on the AP exam. All right, one more. Let's take a look at 5 through 8, which I'm being given a chart. Very important. I'm being told that the function is differentiable, which also implies that it is continuous. So we're trying to estimate the value of the derivative at 2.5. Well, we know the derivative is a slope. So if I can't do slope, then I might do, if I can't do derivative, then I might do slope. So I'm doing a y2 minus a y1. Y2 would be 5 minus a y1, which is 1, over 3 minus 2, which gives me 4. So the value of my estimate of the derivative at 2.5 is 4. Okay, now look at C. It says, if one exists, on what interval is there guaranteed to be a value of C such that the function equals -1? So remember, of our theorems, intermediate value theorem and extreme value theorem give guarantee values for the function. Mean value and Rolle's theorem guarantee values for the derivative. So this is playing off of intermediate value theorem. I need to know between which two um, x values are we guaranteed that the function's going to have a y value of -1. So look what happens here. If you even want to do a little bit of a sketch, I think that it's worthwhile. Okay. So 0 to 0, -3, 1, 2, 3, 5, 4, 2, and 6, 1. Okay. Just do a little sketch of your graph. I want you to see where is the only place that if this is continuous and I connected them, where's the only place between which 2 points am I guaranteed to have a y value of -1? I hope you're seeing it's between these first 2 points, right? So it would have to be between 0 and 1. Now those are x values, remember, those are x values. And the reasoning, because g of 0 is less than -1, which is less than g of 1, right? -1 is between those two y values is essentially what we're saying there. All right, friends, thanks for hanging on with me. We've got 2 more here. C says, if one exists, on what interval would you be guaranteed that the derivative would be equal to 0? Okay. Rolle's theorem, mean value theorem, guarantee the derivative equals a number. Rolle specifically guarantees that the derivative is equal to 0. So remember your criteria. Got to be continuous, got to be differentiable, and those y values have to be equal to each other on Rolle's theorem. So where do you see the y values equal to each other? I see it here and I see it here. So this means that we have to be, C has to be between 2 and 6. And you want to go ahead and state by Rolle's theorem here. By Rolle's theorem, g of x is differentiable and g of 2 equals g of 6. There is a value C so that 2 is less than C is less than 6, where g prime of C equals 0. Okay. All right, one more to go. Number 8. If one exists, on what interval is there guaranteed to be a value such that g prime of C equals 4? Now that 4 should ring a bell. Okay. G prime of C equals 4. Remember, mean value theorem guarantees you a value for the derivative. And what is true about mean value theorem? You got to be continuous, got to be differentiable. And so we're going to use the interval we used here between 2 and 3. By mean value theorem, go ahead and call it by name. There exists a value C between 2 and 3, where G prime of C equals 4. Okay. So I hope that helps with our theorems. I hope you're picking up on the extreme value theorem and intermediate value theorem guarantee us values for the function. Rolle's and mean value theorem guarantee us values for the derivative. Very, very important to catch that distinction as you're working through these problems. Thanks so much for watching. If you have questions, we want to leave them in the comments below. I'd be glad to answer them. Bye for now.